Hi everyone, so today we're going to learn how to analyze a factorial ANOVA in SPSS. So we're going to use the same problem that we used for learning to code the data. So just to refresh your memory, as a budding psychologist, you wonder if you can teach old dogs new tricks. You go to the local humane society and you adopt 10 puppies and 10 older dogs. You attempt to teach the dogs 2 of the standard tricks. One is to sit and one is to roll over. Teaching only one trick to each dog, you keep a record of how many days it takes before they learn the trick. And the results can be seen here in the screen. So we have tricks, age, and days. And 1 refers to sit and 2 refers to rolling over. And then for the age, I dummy coded 1 equals the puppy dogs, and 2 equals the older dogs. And then the dependent variable is the number of days it took them to learn the trick. So that would just basically be the number of days that it took them to learn the new trick. So one thing I would always recommend that you don't forget how you actually coded your data is to enter that into SPSS. So you can just go to the variable view and then click on values, and then you can just type in here 1 equals sit and 2 equals rollover. Add it and I click OK. And for the age, we do the same thing. 1 equals young dog or puppy, and 2 equals older dog. Here we go. So we say OK, and we go back to our data view, and then we're ready to actually analyze our data. So you see that I've just entered in the trick type, so sit. And then here we have roll over, and then we have again sit and roll over. And then we have here the first 10 dogs are the young dogs, so the puppies. And then the last 10 dogs refers to the older dogs. And then here we have the number of days that it took them to learn each of the tricks. So to analyze our data using SPSS, again, we're conducting a 2x2 factorial ANOVA. What we have to do is go to Analyze, and then click General Linear Model, and we click on the univariate selection. And then, of course, we have to think about what's our dependent variable, and that's, of course, the days that it took them to learn the trick. And then our 2 independent variables, also referred to as factors, would go in the second box. Now in our case, because we only have 2 levels of our independent variable, we do not need to do post hoc comparisons. Otherwise you would have to click on here and enter in the comparisons that you want to do. In our case, right, because we only have 2 levels of each of our independent variables, we don't need that. But what we do need is to create some plots, because we want to see how it all looks when we plot our data. So you go to plot, and then I would actually plot it out both ways. So first put trick in the horizontal line, and then age in the separation line. Add this, and then basically do the same thing, only put the age in the horizontal axes and trick for the separation lines. Add that, then hit continue. And then we have some other options here. You could include some descriptive statistics for your variables. That would just be helpful for your results section. So click on that. And then we've done everything that we needed to do. So now we just hit OK. That's going to do our analysis. And then here we go, we're all done. So we can actually look at what we have. So the first box, of course, here is your descriptive statistics that we requested. So you can actually look at all the data that you need. So you have your rows and your columns. So here we have, for the first trick type, so sit, we have the means and standard deviations for the young and the old dogs. And then we also have, for the second trick type, roll over, we have the means and standard deviations for the young and the older dogs. And then, of course, we also have the row and column means for age. So you see those in the total box right here. So that will help you interpret your interactions. So here you have everything that you need. But really what we are most interested in is if we have two significant main effects, and also we want to know if we have a significant interaction. So this is the box that we're really interested in to interpret if our overall analysis was significant. So first off, you can ignore the first two lines where it says corrected model or intercept. We're really not interested in that. What we are interested in is trick, right, our first independent variable, and age, our second independent variable. So those two would be our main effects. So to interpret if our main effects were significant, we would just look over here, right, at the p-value. We want this to be equal to or less than 0.05. If they are equal to or less than 0.05, we know that they're significant, so there's a significant main effect. And it looks like both trick and age actually are significant. So we have our p-values at 0.000, and then also for writing up our results, we'll need our f. So for trick, our f is 162.36, and for age, our f is 30.764. And then last but not least, we're also, of course, interested in our simple main effect, or also called our interaction. So you see this here denoted by saying trick and then asterisk age. So that refers to our interaction. So we see that our f is 11.888, and the significance level, so our p is 0.003. So of course that means that it's significant also. So in this case, right, we have two significant main effects, one for trick and one for age. And so both the trick type that a dog learns has a significant impact on how long it takes them to learn the trick, and also the age seems to play a significant role in how long it takes a dog to learn a trick. And then the interaction here is also significant, meaning that depending on the trick type, the age has a different impact on how long it takes them to learn. So to figure out what this all means and how to interpret the interaction especially, we should look at the plots right here. So again, we plotted both just to see which one is actually easier to interpret. So for the first one here, we have the separation line is for young dogs and old dogs. So the green refers to the old dogs and the blue refers to the younger dogs. And then here we have it separated by the trick type. So either one would be fine to use. I think the one that makes more sense in this case is actually this one, where we have two lines for one for the young dogs and one for the older dogs. So what this is telling us essentially is that overall, right, for the blue line, we see for the younger dogs that it takes them overall fewer days to learn both of the tricks, right? So we can also see that looking at the means and standard deviation. So it seems that old dogs can learn new tricks, but it takes them a little bit longer. The other thing that's really interesting here is that there clearly also is a difference in the two different types of tricks. So we see that there's a steep increase from one trick to the other for both young and old dogs. So it seems that learning to sit is much easier to learn than learning to roll over, as you can see here, right? It takes them more days to learn to roll over compared to learning how to sit. The other really interesting thing is that the interaction here, right, as we saw earlier in the table, is in fact significant. So what does this mean? Right, so here you can see that actually for the simple trick, right, the sitting, it seems that there really isn't a huge difference in the number of days it takes old and young dogs to learn to sit. However, for the more complicated second trick, the rolling over, there seems to be a huge difference here between young and old dogs. Right, so you can see that right here. So this is how you could actually present your data on a poster, right? It would be able to, you would be able to talk about both of the main effects, but also the interaction. So it's pretty clear here that age plays a role, right? The younger dogs learn more quickly, as indicated by the fact that all their numbers are lower. All the days that they took to learn either of the tricks, it took them fewer days compared to the blue and the green line. And then we also see that the trick type plays a significant role, meaning that for both young and old dogs, it took longer to learn to roll over compared to sit. And then you can also nicely talk about the interaction, saying that, you know, there's almost no difference here for young and old dogs, but there's a huge difference for young and old dogs learning the more complicated rollover trick. All right, so this is it for how you actually conduct the analysis with SPSS, and also how you interpret it. And then you can just refer to the handout to see how you would actually go about reporting your results in a research report.